for this event, as this is being organized in the honor of contribution from Professor Ashutosh Sharma for science and technology ecosystem of our country, and that is very important for all of us, for whole country to grow and particularly for youngsters who are there. So anyway, my scientific talk will be a couple of slides, and I can stop anytime, where I will be talking about one part of my work which I will be doing. But before that, I want to highlight that I had privilege to work with Professor Ashutosh Sharma in INSA, as I was INYAS chair and he is INSA president. So I want to just share some of glimpse working with him, and this gives me a very special happiness moment. So this was in fact the first meeting with him when he was DSC secretary, and we wanted to release this all contribution from INYAS. We wanted to release a document which was related to the COVID-19 details, and then of course there are a couple of pictures you can see here for Science 20 G20 events. We have worked together, and I feel always honored being with him in so many events. You can see mostly all our INYAS events he was part of this, and the support that he has given to us for all sort of our activities was really commendable, and you can see it was also highlighted at INSA newsletter. Then this is a special picture. I don't know where Veda disappeared and why. So this is a special picture. You can see we made him, he's always young, and we made him even younger. So by presenting a t-shirt where it is written INYAS. So he always says nobody in science is old, or everyone is young. I am young and you are probably younger. So we made him even younger, and that was also a special moment. Last year we started celebrating our 10th year of INYAS, and there are many pictures where we celebrated together, and this is the picture from last evening. So I covered from 2019 to yesterday evening. So anyway, what we are doing now, some technical part, what we are doing at IIT Delhi. I am from physics department, so though I will be presenting some work which is related to chemistry, and now Tara is not there, so I can speak whatever I want to speak. But she is chemist, hardcore battery person, but she has actually made my life bit easy. After her talk, I removed 4 slides, so that will save at least 35 seconds. But I'm basically hardcore physics person and working mostly on physics projects. So you can see this is what is called the pulse laser deposition, which is used to grow thin films. Okay, so I will not show any equation, conversion and so on, just general things. Okay, so this technique actually is used to grow thin films, and thin film technology, everyone knows that thin film technology is playing huge role in our daily life. Even your glass has coating, this camera has coating, our cars, glasses have coating and so on. So these thin films are very crucial for our daily life, and we try to grow and try to study some of the interface properties and so on. This is another project where we work on a special class of material, what is called Hustler alloy. Hustler was a scientist. More than 120 years back, he found this particular type of material. And what is special in these materials is that these materials, of course, these days, and where we are focusing particularly for 2 applications. One is what is called spintronics. Okay, everyone is having phone, and the data storage capacity is now 200 gigabyte, 300 gigabyte, and so on. Right? Earlier it used to be the pen drive only 1 gigabyte. I remember when I purchased the first pen drive, it was 1 gigabyte only, and now even 200 gigabytes just the small pen drive. So there the spin of electron is playing the role. Everyone knows electron, right? And electron having charge and spin, right? Mostly in electronics we use the charge property of charge property of electron, right? And how this is carrying the information in electronics, basically the electron is moving from one place to other place, and when I am moving from here to there, I will scatter with 3 of you, and then we'll lose some information. So therefore, now people are trying to utilize the spin component of the electron's property and trying to now convert or going
from electronics to spintronics, right? So there are so many advantages, I will not speak. This other part where we are focusing on is how to utilize these materials for magnetic refrigerator applications. So you know, every one of the household is using refrigerator, and all these refrigerators are producing small amount of CFC that is going in the environment. Can we replace all these conventional refrigerators with some type of refrigerator where there will be no CFC? And the answer is yes. And therefore we are trying to explore some of these materials. We have published some work in that direction. And of course everyone knows about the quantum mission of Government of India. We are also trying to contribute in that direction by growing single crystals. I am sure some of you are aware about materials. When we prepare materials, it can be amorphous, it can be polycrystalline, or it can be single crystal. The growing single crystal is the most difficult part. And the first indication whether it is single crystal or not is given by the X-ray diffraction. This is the X-ray diffraction, very simple technique. The intensity here, 2 theta angle here. If you see 00L plane, I am sure some of you have knowledge of basic condensed matter physics. So you can see here 006, 009, 0012, 0018 and so on. That tells us the first glance that this is a single crystal. So these are the three projects, and then what I will be showing some of the results is related to this battery project, where in 2019 or so we started working on this project. And in fact this was possible because of this Center of Excellence which was set up by Department of Science and Technology when Professor Ashutosh Sharma was secretary. And you can see in this picture, I am here, Professor Ashutosh Sharma is here. So this was, this was the release of this Center of Excellence, and I actually give whole credit of this battery project to this Center of Excellence. And therefore, you know, the leadership and the initiative, new initiative at leadership level actually matters, particularly for us, for young researchers. Of course, then we got money, and what are we doing? I will show you some. But then let me tell you, every one of us are using at least 3 or 4 batteries. In my body now I have 1 battery, I have another battery, I have 3rd battery in mobile, and 4th battery is my laptop. So without battery we cannot. Watch also, yes. 5 batteries. So without battery we cannot live, right? And everyone knows that we are utilizing every battery which is lithium ion battery, right? So what we thought that why can't we replace these lithium ion batteries to something else? And of course Tara talked about different variants, but I will talk about the simple one, which is the sodium ion battery, in my opinion. Why do we need to replace lithium? Mainly because you can see it's very interesting thing here. If you look at the whole globe, the lithium is available at very local level, at very few places. You can see here very few patches. In India, no lithium. That's the most important for us, right? Even if you look at around the globe, 0.002% lithium, sodium, you can find everywhere, right? So therefore, of course, the price will be very high. You can see the most important parameter here, the cost. You can see here 400 per ton for sodium, whereas very high number for lithium. And of course, that is not desirable for us, right? So that is the main reason what we wanted to do, but there are of course some challenges. Only some minutes. Okay. So that's what we wanted to do something, and what I want to show you is that the sodium as a green substitute for lithium ion batteries. We can discuss more detail. I will go now fast. This article I last year published by RSC, where I tried to give my opinion that sodium ion battery can contribute towards the India's ambition for net zero. And then what I want to show you only this paper, where you can see we try to replace, this is a very famous cathode material, sodium, vanadium, then something phosphate. In lithium ion batteries, you know that lithium cobalt oxide is the cathode, and also lithium phosphate is the cathode. Anode side we use graphite, right? So we wanted to, and if you do the cost analysis and all, the cathode is contributing the most in the battery cost. So we wanted to study the cathode side, and of course, being an experimentalist, what we have to do, we have to synthesize and then characterize first, then develop the battery, fabricate the battery, and then what we have to do is to test the battery's electrochemical performance. So So though Tara already showed such pictures, but what I want to show you is that on this scale is the potential, this scale is the capacity. So your mobile phone battery, I am sure you know that the number is written 5000 milliampere hour per gram or 6000 or something like that. That's the number here, right? And when we talk about density, density is watt hour per kg. How will get watt hour per kg? If you just multiply this number 120, so this is the potential. Normally we talk about 3 volt battery, 4 volt battery, 2 volt battery, something like that. That's what it is. So this will give you roughly 3.8, and this is the number 120, and if you multiply this you will get watt hour per kg. That is what is the density of that material. And of course we are looking for high density, so that means that we have to either increase this number or this number, right? Now the second important point is that how long my battery can sustain, right? So of course we want our battery life of 10 years, maybe 20 years and so on. So for this purpose we tested the battery life, and you can see again this is the specific capacity here, and these are the cycle number. And for the first time in this paper, this is a very recent paper, we showed up to 2000 cycles the battery life. When I say battery life, what do I mean by battery life? Battery life means initially the battery capacity, let's say if it is 100, then the life is considered in the terminology when it goes down to 80. Okay, so the 80% we achieved in 2000 cycles, and we said that 2000 cycles, considering that I am charging my battery only once per day, I can say that the life is roughly 5.5 years, and that too at 10C. So normally when you charge your mobile phone, I am sure you have noticed that your mobile phone gets charged always around in 1 hour, right? I hope you have noticed, because your charger is optimized in that way, and that way means 1C rate, how fast the ions can move from one cathode, one electrode to another electrode. And this testing what we did is 10C, so that means 10 times faster charge discharge. Okay. So this is what I wanted to show. These plots, of course, don't worry about that. What we did, these measurements are done in Taiwan. During charging and discharging, we want to study how this structure is changing, okay, and whether it is stable or not. So in charging, if I am going there, in discharging I should come back, and that is seen here. You can see all these like going down but then coming up, going down and coming up, and so on. So there is stability. So just I am finishing in 1 minute. There are a couple of more such examples. I will not go into all these details. Yeah, just in 30 seconds I want to highlight this. This is the indigenously prepared paper separator. You know, in battery, one cathode, another electrode, another anode, and then in between a liquid electrolyte, and there is a separator. Normally we buy this separator, and first time, at least to the best of my knowledge, for sodium batteries we tested this paper separator, which was prepared in one of the CSIR labs by our collaborators. So yeah, I am actually done. Thank you.
Thank you.
There are so